Even though the sextant is not used for normal navigation these days, you are reminded that it is one of the best fallback instruments if the satellite network is out of service, and, in 2020, it is still included as a skill that you should acquire as per SDCW. The sextant is a precision instrument used for measuring angles in any plane. The sextant can be used to measure the vertical angle between the horizon and a celestial body at a time. That is called the altitude of the celestial body. If the navigator measures the altitude of the sun and when it passes over his longitude, it is a very easy calculation to find his approximate latitude. However, this is an inshore navigation course and we can tell our latitude just by looking ashore. After a short while, working with GPS around Trinidad, navigators will realize that Toparo Point is around 10 degrees 02 minutes north. Serpent's Mouth is around 03 minutes, and going up the Gulf of Paria coast, Cedros Point is around 08 minutes, Point Fortin is around 11 minutes, Point Pierre is around 19 minutes, Claxton Bay is around 21 minutes, Pt. Lices is around 24 minutes, Port of Spain is around 40 minutes, Carnage and Chaguaramas are around 41 minutes, the north entrances of the Bocas are around 42 minutes, and the Hibiscus platform is around 11 degrees 08 minutes. Starting from south on the east coast, the latitude of Cassia Field is around 9 degrees 55 minutes north. Goleta Point is around 10 degrees 08 minutes north, Point Perdix and Simon Field are around 20 minutes, Manzanillo Point and Darien Rock are around 32 minutes, Belandra Bay and Angostura Field are around 43 minutes, and Taco is around 10 degrees 50.5 minutes north. So coastal navigators do not need sextants to observe celestial objects to find latitude, but can use them to find distances off terrestrial objects. Sextants are precision instruments and should be handled with care. We should pick up the sextant box as if it had left improperly shut by the previous user. When we place the box on the table, we should ensure the handle side of the box is down on the table. A sextant should be taken from the case with the left hand by the frame and transferred to the right hand, which grasps the handle. If you need to place the sextant on a flat surface like a chart table, there are two legs extending down from the underside of the frame, which together with the handle form a base. When you are replacing the sextant in the case, there are often receptacles for the legs. Take care that the legs go into the receptacles. The principle is that if a ray of light is subject to two successive reflections in the same plane, the angle between the first and final reflection is double the angle between the two mirrors causing the reflections. When we place the box on the table, we should ensure the handle side of the box is down on the table. We have already removed the sextant from the box. The manufacturer's certificate and a tool for adjusting the instrument should be the other items in the box. The arc is the curved widest part of the triangular frame. The arc is the plane of the instrument. For horizontal sextant angles, the sextant is used with the arc held horizontally. For vertical sextant angles, the sextant is used with the arc held vertically. The arc is graduated in degrees from about -5 degrees to about 125 degrees. The output from the arc of the instrument is degrees only. There's no need to try and estimate minutes on the arc if the mark is between 2-degree marks. The sextant is named after its arcade. The sextants are fitted with a telescope which is attached to the collimating collar. The height of the telescope can be adjusted slightly for different conditions when taking star sights. The index mirror is perpendicular to the frame. The index mirror is attached to the index arm or bar. There are 4 color shades in front of the index mirror. The colored shades have different densities and are provided to prevent glare from the sun hurting the observer's eye. The shades are arranged and hinged so that each one can be used individually or more than one can be used at the same time, according to the observer's personal preference. The index arm of the sextant can move in relation to the body by turning the micrometer drum or by squeezing the spring-loaded quick-release levers. The levers free the fine adjustment screw in the interior of the index arm and allow it to be moved quickly to any angle. Be sure to squeeze the levers completely so that the screw clears the gear rack on the underside of the sextant. Release the levers and turn the micrometer drum at least one full turn to ensure that the screw has meshed fully with the gear rack. An incorrect reading may be obtained at the drum if this is not done. The horizon mirror is also perpendicular to, and also directly connected to the frame. This one is half mirror and half plain glass. There are 3 color shades in front of the horizon mirror. The colored shades have different densities and are provided to prevent glare from the sea hurting the observer's eye. The shades are arranged and hinged so that each one can be used individually or more than one can be used at the same time, according to the observer's personal preference. The micrometer drum scale and its screw mechanism, not the arc, determine the accuracy of your sextant. The arc is stamped with sufficient accuracy to ensure that you are never reading the incorrect whole degree. Full accuracy in minutes of arc depends exclusively on the drum scale. For example, when the sextant reads 0 degrees 00 minutes, the drum scale will be set precisely at 0, while the index line and the 0 on the arc may be slightly out of alignment. As you are concerned only with reading whole degrees on the arc, this difference is not significant. The sextant should be checked and, if necessary, adjusted prior to each time it is used. A correctly adjusted sextant has both mirrors perpendicular to the frame and they have to become parallel to each other when the arc and micrometer scales read 0. Check if the index mirror is perpendicular to the frame, as follows. Set the instrument at approximately 50 degrees. Hold the sextant horizontal and arc away about 8 inches from the eye. Look with one eye into the mirror so that the frame arc is reflected in the mirror. Move the instrument until you can look past the index mirror and see the actual frame arc as well as the reflected arcade. The 2 arcs should appear as one continuous curve. If they do not, turn the adjustment screw at the back of the index mirror until the 2 arcs come into alignment. Check if the horizon mirror is perpendicular to the frame, as follows. Night method is to observe a star. The sextant should be held vertically and the index arm set to 0 degrees. A bright star with a low magnitude should be observed through the telescope. If the true and reflected images are shown side by side, then side error is present. Daylight method is to set the index arm to 0 degrees and holding the sextant at a small angle of horizontal. You should look through the telescope and observe whether the reflected and true horizons are misaligned. In this instance it will appear that one is slightly higher or lower than the other. If this misalignment is present, then once again it can be said that side error is present. If side error is present, you should adjust the screw located on the back of the horizon mirror furthest from the plane of the instrument. To be certain that the sextant is now correctly adjusted, check to see that the sextant is still set at 0 degrees 00 minutes and the real and reflected horizons remain in a single line when the instrument is rocked or inclined from side to side. On a correctly adjusted sextant, the real and mirror horizons remain in a single line when the instrument is rocked from side to side. While you should know how to adjust your sextant for index error, it is not necessary to remove it entirely. It is standard practice to simply note the error and then correct one's readings for this amount each time the sextant is used. 6 minutes or so of index error is allowable. Hold the sextant in your right hand and look at the sea horizon. By moving the index arm in the micrometer drum, line up the real and mirror horizons so that both appear as a single straight line. Read the sextant scales. If the sextant reads 0 degrees 00 minutes, there is no index error. If the sextant reads anything but 0, there is an index error, which must be added to or subtracted from each subsequent sight. For example, if the sextant reads 6 minutes, the 6 minutes is subtracted. If the sextant reads -6 minutes, the 6 minutes is added. For an index error of -6 minutes, the micrometer drum will read 54 minutes. The index error is one of the adjustable errors and affects the observations. The other adjustable errors are the error of perpendicularity. That's when the index glass is not perpendicular to the plane. And the side error when the horizon glass is not perpendicular to the plane. Index error is defined as the error caused by both the horizon and the index glass not being parallel to each other. Whether you actually correct a sextant or not, it would be advisable to check the index error by observing the true and reflected horizon with the sextant clamp at 0. If they are not in line, turn the micrometer screw to bring them in line, and the reading shall be the index error. The error shall be on the arc if the reading is positive, and off the arc if the reading is negative. On the arc errors are subtracted and off arc errors added. The sextant has the potential to suffer from the following non-adjustable errors that can only be solved by returning the instrument to the manufacturer for servicing and repair. Centering error is when the index arm does not pivot along the exact point at the center of the arc's curvature. Prismatic error is when the faces of the two mirrors are not parallel to each other. Shade error is caused when the faces of the shades not being parallel to each other. Darkened eyepieces are available for some sextants. Graduation error. This error is caused by imperfections on the arc or the scales of the micrometer or vernier. Worm and rack error occurs by failures in the worm and rack gearing of the micrometer, and main arcade collimation error occurs when the telescope is not parallel to the plane of the instrument. Find the lines on the arc that are closest to the index line on the index arm. The index line is usually somewhere between two lines. The correct reading is usually that of the lower value, that is, the line to the right of the index line. Note, when the index line is very close to a line on the arc, check the reading at the micrometer drum to be sure that you have taken the correct whole degree. To read fractions of a degree, use the two scales involving the micrometer drum at the side of the index arm. The outer revolving drum scale indicates minutes of arc. 1 minute equals 1/60th of a degree, and the stationary vernier reads to 210 ths of a minute.